All right, welcome everyone. Today we are going to be working on 9.4a. We are going to be talking about another equation that you guys are going to be adding to your list of equations. Today we're going to talk about something called series. And the word series, it means it's the sum of all the terms of a sequence. Okay. We're going to have two different types. Today and tomorrow, we're going to talk about finite ones. After that, we're going to talk about infinite ones. So finite ones mean it ends. We have a first term and it goes to a last term. And infinite means it's going to go on forever. So we do have two different equations that we're going to see for those two different types. Today, we are going to have the arithmetic series. Okay, so it's shown by this equation right here. So if you would please take a moment, pause, and add this to your list on the front cover of your note packet. Okay, I'm going to assume you paused and you added this in here. So All right, so how I have this memorized still to this day, we have a capital S, and how I have that memorized, it's helping me find the sum, or means our series. So that's where that S is coming from. The n in our equation, it represents our number of terms. So if you go out 10 place values, that or 10 places in our sequence, that's where you'll put that 10. The divide by 2, that's just in our equation. The A1 represents our first term, we know that, and that AN, that represents our last term in our sequence, okay? All right, so we have these two problems here. It says that we are going to take these and we're going to find their sum. I know some of us are thinking, Bills, why wouldn't we just plug these all in our calculator? We want to assume, what if we had to find 1 through the 100th term? You wouldn't be sitting there adding up all those 100 numbers. I know these two, they're small and it would be really easy to throw in your calculator. What if you had large ones? So we'll start off on these two are easy to, where we only have 6 numbers. What if we had future ones that had more numbers? Okay. All right, so this is our first term, second, third, fourth, fifth, and sixth. So like always, I'd like you guys to list what we have. So we know our A1 is 3. Our last term is, our last term there is 38. Our last term is 38, and then our N, it went out 6 terms, okay? All right, so we're going to plug this into our formula. So we're going to be using a capital S because we're doing series. All right, so we have our S for our series or our sum. We have our sixth term, so we are going to write a 6 here. And then our equation says we take our 6 divided by 2, in parentheses, our A1 plus our AN. From here, it's up to you how you want to plug it into your calculator. If you want to like simplify it a little bit and then plug it in. So for example, I like to simplify the fraction, so I'm going to turn that into a 3. If you also want to simplify this stuff inside here or leave it as is, and then plug this in, you can certainly plug the entire thing in your calculator. If you do that, remind your fraction needs to be in parentheses if you do want to plug the whole thing in. And then when we plug that in, we are going to find out the sum of all of those numbers is 123. So again, I know some of us are thinking, Bills, why won't we just plug all those numbers in and add them together? We can certainly do that, but reminder, we do have problems where it's not going to be just 6 numbers, it's going to be a lot more. Okay. All right, so now we have this next one. We're going to do the same thing. This is my first, second, third, fourth, fifth, sixth, and seventh this time. Notice our numbers are getting smaller, which tells us they're subtracting. Our A1 is 5. Our AN, or our A7, is negative 19 out there. And our N, that is the 7th term. Okay. So now we're going to plug this into our formula. So I'm going to say S7. We have 7 divided by 2. our 5, and notice it's going to be 5 plus negative 19. Sorry, that's crunched in right there. So make sure that you have that negative on the 19. Again, if you want to plug this whole thing in your calculator, you can put parentheses around your fraction, or if you want to simplify it a little bit, I divided those, I combined the parentheses, and now I'm going to plug this into my calculator. And when I do that, I get S7 equals 49. So that is that equation. Now notice I'm giving you everything. I'm giving your A1, I'm giving you your AN, and I'm giving your N. So these next problems, I'm not going to give you all of that. And as I said, these are ones you would not add them all together in your calculator. You're going to have to use the equation. So reminder, when we're doing these problems, we want to list out what we know and what we don't know. Okay, so we always need to know these things here because reminder, we are going to be using this equation. And if we do not know those, reminder, we're going to fall back on this equation, our explicit arithmetic equation, to help us find anything that we are missing. Okay. All right, so I have this first one here. We have our first, second, third, fourth, and then, dot, 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 9, 9. This dot, dot, dot means we do not know our n. That means we don't know how far out 99 is. We don't know how many terms that is represented in the dot, dot, dot. Okay, so let's list out what we know, find out what we don't. So our A1, we see that it is 4. Our n, as I said, that's what we're finding here. We want to know what dot, dot, dot means. We know our last term, so I'm going to represent that with that an. We know that's 99. And there is one other thing we know. We see our pattern here. It goes 4, 9, 14, 19. So that means our d equals 5, that they're adding 5 every single time. Okay, so now we're going to use our explicit formula that we've been doing the last couple of weeks here. And we're going to plug in that to help us find our n. So our an is 99, so we're going to say 99 equals, our a1 is 4, our n, that's what we're trying to find, and then our d is 5. Okay. I'm going to do two things at once here. I'm going to subtract that 4 over, and I'm also going to distribute the 5 just to kind of do a couple steps at once. So I'm subtracting the 4 from the 99, and when we do that, we're going to get 95. I'm also going to distribute that 5, so now I have 5n minus 5. Okay. Now from here, we're going to solve for n, so I'm going to add 5 to both sides. So I'm going to have 100 equals 5n. And then we're going to divide by 5, and our n is going to equal 20. Okay, now reminder, that's not our answer. Our answer is we're going to be using our sum equation. Okay. All right, so now we have all of our information, so now we can plug it into our equation up there. So we now know our n is 20, so we're going to say S20, and we're going to have 20 divided by 2, and we have our A1 plus our AN, which is 99. Okay. Again, it's up to you. You can plug in how much you want. You can plug the whole thing in. If you are going to plug in the whole thing, put parentheses around here. And when we plug this in, we are going to get our S20 equals 1030. So as you can see, that's why we have these equations, because you wouldn't want to say 4 plus 9 plus 14 plus 19 plus, you wouldn't want to do that pattern because that's a very large number. Okay. All right, so let's do another one of these. I want to tell you guys a quick rule of thumb. When you don't know your n, reminder, n represents a term number. So because it represents a term number like your 5th term or your 6th term or your 100th term, it should always be a positive whole number. If it is not a positive whole number, you know you have done something wrong. So your n should always be a positive whole number. Okay? All right, so let's take a look at this one. This one, ooh, I'm starting with 30 and then it's going down to negative 26. So that tells us they're subtracting something. Our A1, it is 30. Our N again, that dot, 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 that means I don't know what it is. To jump from 30 to 23 to 16, that means they are subtracting 7. And we also have our AN out here. We don't know what the term number is, but we do see our last term is negative 26. Okay, so now we're going to plug into the explicit formula. So we're going to say negative 26 equals 30 plus Rn, because that's what we're trying to find, n minus 1. And we are going to put negative 7. All right, again, I'm going to do 2 steps in one. I'm going to subtract that 30 and distribute the negative 7. Watch out for the negative there. It's going to make everything in the parentheses switch signs. So I'm minusing the 30, so I'm going to have negative 56, distributing the negative 7. So now I have negative 7n plus 7. I'm going to subtract the 7 from both sides. So now I have negative 63 equals negative 7n, and I'm going to divide, and n equals 9. And as I said, it needs to be a positive whole number. Check, it is. All right, so now that we have all of our information, we are now ready to plug it into our formula. So I'm going to say S9. We're going to say 9 divided by 2. We have our 30 plus negative 26. Watch out for that negative there. Again, you can plug the whole thing in, and I'm going to crunch the answer right in here. Sorry, guys. And I'm getting that our sum of 9 equals 18. The negatives made that number smaller. Okay. All right, so that's how to do the problem if you are missing your n. The next two, if you notice our dot, dot, dot is somewhere else, and this time I'm giving you your n. Okay, so let's see what we are missing. So I gave you your A1 is 1. Our n, it literally says it's 12. Our pattern here, I'm adding 2.5 every single time. And this time there's a dot, dot, dot at the end, so we don't know what that is. We are trying to find our AN. We know it's the 12th term, but we don't know what that term is. So we are going to use our equation to find it. Okay, so I'm going to say AN equals, that's what we're trying to find. And now we're going to plug it into our arithmetic explicit formula. So I'm going to say 1 plus, I gave you guys your n, so I have 12 minus 1, and we know the pattern is 2.5. Now, if we look inside here, there's no letters to solve for because we are solving for our an right here. So to be honest, you can grab your calculator, plug this whole thing in. If you do want to simplify this to 11 real quick for your calculator, you could certainly do that. Or to be honest, again, you could plug the whole thing in. And when we are doing that, when we plug the whole thing in, we are getting our AN equals 28.5. So as you can see here, if I give you the N, it's way easier because you don't have to solve anything. You just got to plug it into your calculator. We now have all of our information, so we can plug it into our series equation. So I'm going to say S. It is our 12th term. So I'm going to say 12 divided by 2. Our A1 plus our AN that we just found. Reminder, you can plug this whole thing into your calculator. If you want to take the 12 divided by 2, turn it into a 6 if you want. And when we plug this whole thing in, we are getting 177. So as you can see, finding your AN is way easier than finding your N. All right, we're going to do one more problem. This one right here, it has kind of a challenging thing. As we see again, we have dot, dot, dot at the end here. Our N equals 10. Our A1, that's not hard to find. That's our 20. Our N is 10. Here's where I think maybe some people are struggling. So right now we see that the numbers are going down. It might be kind of difficult for some of us to see what they're adding or subtracting by. So a reminder, if you want to know the difference between these two, I'm going to take my A2 and I'm going to subtract my A1. Okay. When we do that, we get negative 1.7. So that tells me they are subtracting 1.7 every single time. So if you're never not sure what the pattern is, you can take your A2 minus your A1, and that's how you can find your D there. Okay, our AN, again, that's what we are trying to find. I'm going to plug this into my explicit formula. So we're going to say, I'm going to write it down here, AN, our A1, plus our n minus 1 times our d. And notice there's that negative there. Again, you can just plug the whole thing into your calculator. If you want to simplify the 10 minus 1 to a 9, you could. And what I am getting here is 4.7. Okay, and now we have all of our information, so now we can plug it into our series equation. And so I'm going to say S, our n is 10, so we'll have 10 over 2, our A1 and our A7 that we just found. Plug the whole thing in your calculator, and we are getting 123.5. All right, so your homework today, ladies and gentlemen, will start out easy, like the first two problems where I will give you everything, and then you'll have these problems where maybe I don't give you your n, maybe I won't give you your an. And reminder, your n always needs to be a positive whole number. Reminder, finding your an is super easy. You just plug everything into your formula, plug it into your calculator, and it will give you your answer. Okay. All right, we have two word problems left, and then we are done. They're very similar to these two that we just did, that I'm not giving you all the information, and that's how we will solve them. So this says right here, what is the sum of all the even integers from 2 to 100? Even integers, so that means our 2, 4, 6, 8, and integers meaning they are going to be whole numbers, okay? So basically, it's like the problems we just did, that we have 2, 4, 6, dot, 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 and we're going to 100. So we want to know if we added up all of those numbers, all those even numbers from 2 to 100, what would that be? Okay, so let's go through. Let's talk about what we have and what we need to find. Our A1 is 2. Um, our N, now I know I have some people right now who know it, but I'm going to show people why our N is our N. So I'm going to put a question mark on my N. We know our AN is our last one, so it's 100. And we also see our pattern here. If I'm going 2, 4, 6, 8, that, who do we appreciate? Sorry, guys. That means they are adding 2. Okay. All right, so let's plug this into our formula to help us find our N. So I'm going to say 100 equals our A1, trying to find our N, and our D in the back here, it is 2. I'm going to subtract the 2 here, and I'm going to distribute this 2 here. So when we do that, we're going to have 98 equals 2n minus 2. I'm going to add over the 2 to both sides, and I'm going to divide by 2 on both sides, so n equals 50. I think I have some people that might have already known that. They might have said, Bayles, if I have 2 through 100 and it's only the evens, it is half the number. So I might have had some people who have already known that. And now that we have all of our information, we can now find the sum of these. So we can use our series equation. So I'm going to say S50, and we're going to say 50 divided by 2, and we're going to have 2 plus 100. Again, you can plug the whole thing in. If you want to simplify some things, it's up to you. And when we add our first 50 integers, what we get is 2,550. All right, so there we go. So that is how we do that with a word problem. We have another word problem. This time it's dealing with money. Okay. So it says a company will pay $10,000 bonus to a salesperson at the end of their first 50 weeks if they make 10 sales in their first week and then improve their sales 2 each week. One salesperson qualified for the bonus with a minimum possible sales. How many sales did that person make in 50 and all together? Okay, there's a lot going on here. So this one, we want to know what is A50, so meaning what is our AN, okay? This question is, what is our S50, okay? All right, so our pattern here, ladies and gentlemen, is we have our first week was 10, and they're adding 12. So it'd be 12, 14, dot, dot, dot. We don't know our last term. That's what we're trying to find. That's that A50. But we do know it lasts for 50 weeks. So we know it's going to be N equals 50. Okay, so again, this should look like one of our equations from before. So we know our A1 is 10. Our N is 50. We are trying to find our AN. And our pattern here, they're adding 2 every time. Okay, so I'm going to take my explicit formula to help us find our AN. So I'm going to say AN equals our A1 plus our N minus 1 times our D. So reminder, we're finding our AN. It's our easiest one because you can plug the whole thing in our calculator. And when we do that, our AN or our A50 equals 108. So that is actually our first answer. So someone would have to have 108 sales on that 50th week. Okay. Now we want to find out if a salesperson did this, what is the sum of week 1 through week 50? So we're going to say S50, and we're going to take 50 divided by 2. We have our A1 plus our AN that we just found. And again, we're going to plug the whole thing into our calculator, or simplify if you would like. And all together, this salesperson throughout these 50 weeks did 2,950 sales. Okay. All right, so this is the next equation that you are adding to your list of equations. Reminder, it should go into the arithmetic section. So if you have not yet done so, please make sure you have added this equation to your list at your front cover. All right, thank you.